Hello friends. So in the last video, we have learned about how to describe your data on the basis of certain commands uh, to calculate the mean, median, mode, standard deviation, variation, skewness and kurtosis, and learn many commands. And also we have learned about the continuous and categorical variable. Now in today's video, there is one more method for the description of data, that is through diagram. So one way you have to describe the data on the basis of certain numbers like mean, median, mode, and another way you have to describe your data on the basis of certain pictures, certain graphs, that is data visualization. So let's go to our software. So let me clean my old station or console, control L. So this is my window, and I have written all the command here so that our time will save. So these are our command. Mm, So this is our old R script. Uh, if you have seen old video, so you remember that these are the ID. 1 to 8, these are the number of observations, and these are our variable. Like we have gender, that is categorical variable. We have age, continuous variable, weight, continuous variable, height, continuous variable, cholesterol and income is also continuous variable. And we have made a social data frame. So let's run the command, and these are variable added in global environment. Let me highlight my cursor so that it is easily you to see my cursor movement. So let's attach our social data, activate social data. This is our social data. Attach social data, run. So let me make my plot area a little bit broader so that you can view easily. So the first command is plot. Plot weight and cholesterol. So we have to plot. We have taken two variable, that is weight and cholesterol. Let's run the command. So here you can see that a plot is generated. Whenever you do any working in the R script, so the data representation in the form of graph, pie chart, any, it will display on this window pane, that is plot. All your plot diagram will display in this pane. So here you can see that weight and cholesterol, and this is your axis, x and y axis, and your data is represented here. So this is our first command. If you want to know more about this command, anytime you can type help, and in bracket you can type plot. So for example, let's run the command run. So here you can see that the default scatter plot function. In this function, you will get the description, scatter plot. You will get the command, what are the command, and what are the different kind of argument you can give. So basically, argument means uh, certain changes in your graph. For example, you want to change an x-axis graph, y-axis graph. You want to change certain colors. You want to change the size of the x and y axis. You want to change the main theme, the name of the variable. So all these are argument. You can practice all these argument. Likewise, you go here, you can see argument, that is x and y, type, xlim, xlem, log, that is the main. If you want to give title, you have to type main, that is, for example, main, and your title weight and cholesterol. Likewise, you have xlab, ylab, x-axis, y-axis, and these are the all argument you can practice. And these are the detailed explanation of your arguments. And these are the some references for you. So let's run our command again. So here what we have done, we have plot, use the command plot, weight and cholesterol, and main means main title, weight versus cholesterol. Here our title is shown. Let's again go for the command. The command is name plot, weight and cholesterol, two variable, main title weight versus cholesterol. And here, like I said, you the argument, different type of argument. So here I have taken the argument of x lab, that is weight, y lab cholesterol. You can interchange. For x lab you can take cholesterol, and y lab you can write weight. PCH, that is principal character, that is 10. 10 is the size. COL means color. Color is blue. So for example, I change the color RED, and let's run the command. So here you can see that these are the point, the color is changed. If any movement you want to change, again type blue and run the command. You will see that the color is changed. So likewise, you can change many type of colors, their size. You can change the numbering system here. You can change the main title. If you want additional main title, you can add this. So all this option is available for you. Let me resize my plot so you can clearly see. For example, you have many argument here. Likewise, we have add one more LAS equal to 1, and let's run the command. So here you can see that the icon is changed, the size is also changed, and for the LAS it means that your numbering is also changed. Second, you have text command. So if you want to add certain text in your plot, for that, weight versus cholesterol same, CEX, that is the size of 0.6, PUS position 4, color red. So let's run the command. So here you can see that 4 number wise we have 8 observation, and it's shown that this is the number 1 observation. Likewise 2, 3, 4, 5, and shows that which observation. So these points represent 5 observation. Likewise, we can change the position, we can change the size, and also we can change the color of the observation. Next command is if you want to bifurcate the data on the basis of gender. So again, text, weight and cholesterol on the basis of gender, and size is 0.6, position 4, and color is blue. So let's run the command. So here you can see that the name of the gender is displayed, that who are the male and who are the female in your 8 observation, like male, male, female, and likewise female. So you can change the position anytime, 1, 2, 3, 4. You can also change the size and color of your observation so that it is easily visible for others. Likewise, you have another command text, weight and cholesterol. If you want income to show there, same size, position same, and yellow. Let me run the command. So here you can see the yellow color is added and income is also shown here. Many times it happens when you uh, give arguments like you have gender, income. So when you were put new argument, so many times your argument is override here. So you have to change the position. For example, let me change the position here, 3, and run the command. So here you can see that it is not visible. Let me change the color so that it is visible to you. Blue, and here you can change white, yellow. Let's again run the same command. Here you can say it is visible. So this observation has 50,000 income. These observation have 35,000 and likewise 7,000. These all have their income shown here. So in this plot, you can mostly you can add 4 variables. You can easily see left and right side, up and down side. If you add more than argument, so it will not be clear to see because there is only 4 position that easily visible to the outsider. So make sure you have only add 4 option here and also change the color so that it is visible. Like you see that I have given yellow for male and female, but the color is not visible. So you can change the color. Any color you can choose here and run the command again. So likewise, if you want to add certain text here to the title, M text, effect of weight on cholesterol. Again run. So here you can see that another text is added in the main title. That is the effect of weight on cholesterol. You can change this text and move in right direction, left direction, above and below. So these are the argument you can change. For example, M text effect of weight on cholesterol, side 4, line 0, center and column 2. Let's run the command. So you can see that effect of weight on the cholesterol is shown in the right hand side. So if you want to change the position anytime, you can change position 2. Again run the command. If you want to change the position 1, let's run the command. So position of income is changed. Likewise, you can change many argument you can apply and practice. Say for example, M text. If you want to change the line, if you change the side, that is 1. You can change to 3. Let's practice. Run. It's already 3. If you want to run, here you can see that effect of weight is on the second side. So that is 1, 2, 3, and 4. You can change the side of your subtitle. Next, if you want to see the correlation of variable between weight and cholesterol, so the command is COR weight and cholesterol. Let me uh, choose simple math so that it is visible to you. Okay, now our graph is simple and all the option removed. If you want to see the correlation weight and cholesterol, let's run. So here you can see that the correlation is minus 0.08. Again, if you want the text to include in your plot, this plot diagram, the command is text. X is equal to 60, Y is equal to 35, label R is equal to 0.55. Let's run the command. So here you can see that R 0.55 is inserted. And what is X and Y? If you don't understand, X, here you can see X is 60 and 35. So that is X, that is 60 and that is 35. This is the point of intersection, that is R is equal to 0.5. Likewise, if you have many arguments, so let's again run the command with total all the argument, that is plot weight and cholesterol. Main title is weight and cholesterol, X lab weight, Y lab cholesterol, color is blue, alias 1, column main 3, front main 3, column dot X is 2 and column lab 4. Let's again run the whole command. So here you can see you will get a very refined plot. Weight cholesterol, cholesterol, likewise you have number, you get a very good plot. If you want, anytime you want to save this diagram plot, so go to export and copy to clipboard, click copy plot, open your Word file, click here, just wait, paste here. If your Word is not working, you can again copy to clipboard, copy Word, you can paste here. If it is none, I have changed the color. You have many other option. You can save the PDF, save as image. For example, if you want to save image, click here and image is saving in the R script. Likewise, let's go to another command, PAR BG equal to white. If you want to change the color of this plot, uh, let's change it. It's actually white. Uh, it's already white. Let's change it red. So here again, run the command plot weight and cholesterol. So here you can see that the plot is red. So let's change this color. Default is white so that it is easily visible. White plot. So now it is white default. So next command is for you is scatter plot. Always remember, in the previous video I have also shown you, and in the PPT, when you give a command is always followed by a square bracket, circle bracket, and whenever you have variable is always followed by square bracket. So always remember this. So if you want to scatter plot to the categorical behavior, so categorical variable is plot cholesterol tilt weight. Tilt is also sign in the keyboard in the upper side, uh, left hand side to the one key with shift and tilt sign. So let's run the command plot, and this is our scatter plot command, that is point cholesterol gender, it is in the square bracket, tilt weight gender in the square bracket, main title weight and cholesterol, X lab weight, Y lab cholesterol, color is red, and PCH is principal character 16. Let's run the command. So here you can see that the change in the color of the observation. Like we have 8 observation. These are different observation and these are different observation. Which differentiation through the sign. Let's again uh, on the basis of next gender that is female. So these are your male who are in the red circle. Same command cholesterol gender for the female, gender female, weight, X lab, Y lab, color and PCH. Let's run. So here you can see that the red represent male and blue represent female observation. Likewise, you have if you want some regression line command. So to the categorical variable, the command is AB line LM that is cholesterol. Likewise, I have said you is it is in the circle and gender is categorical variable. So it is in the square bracket. Gender equal to male, tilt sign, weight, gender equal to male, one color 2. Let's run this command AB line. So here you can see that this line ripple male line. Again you have AB line for the female, same command. Let's run. So here it is for the female. And next command is legend 8535. Legend C is equal to weight and PCH 90. 19. Let's run the command. So the weight is 90. Here you can see that I have given 85 and 35. So that is x-axis, that is 85. That is the sign 85 here and 35. So this is the 35. So this is the point of intersection. Let's again go to a command. So now we want one or two categorical variable. So we change the data set and this is our data set that is ID, weight, gender, smoking and tumor. That is my data. So let's work on this. Select the data and run. Your data is added in global environment. Now again this there are two rules in the working of R. So left hand side basically if you see left hand side and right hand side there are two sides. uh, I have told you that count this sign less than sign dash and table smoking. So this less than sign or equal to sign that is same. This left hand side where I have written the count, it is the left hand side. Liberty means you have the choice. You can write anything here. You can write the name. Your name is also can be written here. There is no problem. But right hand side is the rule. That is command. You have to put exact command to run correctly. So this is right hand side. Make sure always you have correct command, correct comma, separation and brackets. So this is the sign, less than sign, dash, table. This is the command. So you have to always give correct command. Otherwise, always show you error or the command will not execute properly. So let's attach our data. That is my data frame. Okay. So the next command is count. Count table smoking. So this is our command. Smoking is our variable. The command is table. So let's run. Again run count. So here you can see that smoking. Yes. Three number of three are no smoking. So for yes, there are four smoking. Four people are smoking. If you want percentage, the command is percent, less than sign, dash, count. We have already uh, calculated. Divide by 7, number of observation is 7, multiply by 100. Again run the command, run, and percent. So here you can see that yes and no. 57% say yes and 42.8 is says no. Next command is if you want two categorical variable. Okay. So command is same, count, less than sign, dash table, smoking and gender. So let's again run. Here you can see that command is executed, count. So here you will get a uh, matrix. So here gender, smoking, female and male. So two female, no smoking, one male smoking, and yes, female, two, yes, smoking, and for male, two, yes. If any movement you want any kind of help in all these commands, you can simply type help and bar plot. Any command. When you run, here you can get the help menu where you get the all the arguments. We have put x-axis, y-axis, main data, the augment description, and also the references and command for your reference. So the next command is bar plot. If you want to have a bar plot, so you can get the bar plot, run again. So here you will get the bar plot for the same gender basis. Bar plot, count, columns 2 and 3. So you have differentiate two color. So male and female and smoking, not smoking, smoking, not smoking. Likewise, you have many command you can add here. For example, let's add comma beside T, again comma, density C 20 30, comma, angle 30, comma 60. Let's see. The command is right. So we have added certain argument like beside, density, and angle. Out. And one more argument here. Return error in the command. Uh, let's go to next command. There is certain error. I have to check the argument again. So if you want grid, the command is grid. So here you can see that a grid is also shown. Your whole data, female and male, smoking and non-smoking is divided into the grid. Next command is pair. If you want pairs, so the command can be pair. So pairs, tilt, height plus weight plus cholesterol plus age. We have taken all the variable, social data, and main skip is scatter plot. Again, run this. So here you can see that a scatter plot is presented here. And these are the variable. Say for example, these are the scatter plot of height and weight. And these are the scatter plot for the height and weight and cholesterol. Likewise, you have these scatter plot. Next command is mosaic plot. That is count column 2 and 3. Let's run this. So here you can see that your data on the basis of gender, male and female, and smoking count. So here you can see the larger the portion, it means it represents larger portion. For example, this is the larger portion, female, no smoking. Next you have, if you want pie chart, that command is pie count, radius 0.8, color 3 and 4, density 30 and 60. Let's run. So here you can get a pie chart. At any moment of time, you can change the radius, you can change the color of this pie chart, you can change the density of this outer or inner circle, and you can work with this. So let's move to another command. If you want any kind of help, again type help and py run. So you will get the help. Likewise, if you uh, want plot tricks, this is also a package. Click install packages, wait for few minutes, then attach activate plot tricks, library plot tricks, and the command is py 3D count. Run this. So here you will get a pie chart. Again, if you want any change in this pie chart, you have many argument like you have count, radius, color, density. So you can change pie chart, you can give numbering. Again, type help and pie, run the command. So here you can get the all the argument and command you can use here. You can change the radius, you can change the density, angle, you can change the border anytime. So next is histogram. Always histogram is always plotted for continuous variable. So let's attach empty car. You have already seen the previous video. So empty car is a default save file in the R. Attach empty car, again empty car. So here your data is shown. You can see that empty car. These are the car. These are the variable. Mileage, cylinder, dispersion, horsepower, uh, VSNA, virtual, automatic, gear, and carb. So let's move another command, that is hist, mpg. On the basis of this mpg variable, let's prepare a histogram. So here you can see the histogram of mpg is clear. Like you can change the argument hist mpg color 4 ls1 frequency t. Let's run this. The color is changed. Color is 4. You can change the color 1, 2, 3, 4, and the color will change from red, yellow, blue, and you can practice the command here. Next is PAR M Fro C2 by 2. So this command is if you want to have many histogram, so you can have combined histogram on the one page. For example, let's run the command. These are the command. Here you can see that in the database. Let's see our database. So we have taken VS and AM. Okay, that is AM is automatic or VS variable, two variable. Here you can see the command is histogram mpg. This is MPG, and on the bracket, that is AM0, color 2, density 30, frequency T. Again MPG, AM1, color 3, density 30, and frequency T. Next is MPG, but for VS, equal to 1, color 4, density 30, frequency. Then HIST, MPG, VS equal to 0, color 5, density, and this. Let's run this. Run. So here you can see that histogram of MPG AM. Again run. Histogram of MPG 1. Then you have MPG VS 1, and likewise. And if you want all these four graph in the same diagram, the command is PAR M F row C 2 by 2. Let's run this command and again run this. Let's see. One, first histogram, this command, then again second histogram, MPG AM, third MPG-VS1, and MPG-VS0. So all your histogram, four histogram on the same page. If anytime you want help, the hist command, type help and hist run. You will see all the argument here. Next is your command is for stem and leaf plot. It is used to plot the normality of data. So let's again use the data like we have used empty car previously. Orange is also a default data. Let's run this. This is the data. Let me show you. So that is tree, that is the age, that is the circumference of the tree. So let's activate the orange file, orange data. And now again the command is stem age. Let's show me, see the data for your confusion. Age, the tree age. So the command is stem age run. So here you can see that this is the stem and leaf prepare. It is used to check the normality of your data. Let's move to another command. So we have previously we have social data. Let us attach the same file, social data, and the command is plot. Again, check the plot ID, cholesterol type P, mean type P, CX size. Let's run this. P ID and cholesterol. Okay, some variable is missing here. Let's move to another command. So, likewise, we have another package that is tooth grow. Attach this. The package is tooth grow. Click. This is your package. Default here. That is the lens. That is supplies. That is the dosage. So let's make a box plot for this data. So the command is box plot. Lens. That is the lens. Tilt dose lens and dose we check. Data tool booth, mean length of the tool booth. Y lab tool booth length. Let's check the command run. So here you can see that a box plot is presented here. So here is the dosage, here is the tooth length, or and these are the XY axis, and this is your box plot. Likewise, you have another package that is ggplot2. Let's run this. Okay, and again we have a default database in the R, that is diamond file. Let's run this. Here you can see that a diamond file is activated. that is the diamond carat, ideal, premium, gold, premium, very good. That is the carat of the gold, diamond. That is the color, that is the clarity, depth, stable price, and likewise XYZ. So let's uh, apply another command, that is ggplot, that is diamond. X is equal to clarity. This is clarity. Command is geom bar fill this theme minimum. Let's try this. So here you can see that the ggplot is inserted here. And if any moment of time you want certain changes in ggplot, so you can type help and ggplot. Your all argument will be shown here. So next is your scatter plot. Let's install this from the package. Scatterplot 3D. It's installed. Let's activate. The command is library scatterplot 3D. And the file is default file is IRIS. Let's run this. So let me show you for your understanding. So this is our file IRIS. This is the file sepal length, sepal width, petal length, and petal width. So let's attach this file, activate for the command. The file is attached, and this is the command scatterplot 3D. File is IRIS and 1 is to 3. Let's run this. 1 is to 3. 1 is to 3 means we have taken, that is 1, that is 2, and that is 3. Sepal length, sepal width, and petal length. Let's run the command, check it. Oh, here you can see that is sepal length is here. So I have not cleared the already prepared the box plot. So that's why it is overwritten here. Let's clean my environment. Okay, now it is okay. So next is your package is Data Explorer. Let's run this library Data Explorer. Attach empty car, the previous one. Attach the database empty car. Then if you want histogram, plot histogram for the same empty car, let's run this. So here you can see that a histogram is prepared for all the variable of empty car. You remember, maybe remember MPG, horsepower, gear, and dispersion cylinder, all the histogram here. If you want density, again run. So you will get on the basis of density and value. If you want correlation, plot correlation, you will get the correlation here. So in the empty car. So here you can see that uh, the dark red one, and then there is a very light red one. So the here it is written that this is positive correlation where the picture is very dark, and if you this side it is -1, that is the negative correlation. So likewise, if you want more argument, you can type plot plot, and these are all the argument. Like I have used histogram, density, and correlation. In the package Data Explorer, you can use all these functions for different kind of options. So let's move to another uh, one more package, that is DY graphs. Let's install this. Okay, I have already installed the package. Uh, then you have to activate the package library package, and let's run this command, dy graph nhtemp main you have a temperature. Let's run. So here you can see that your dy graph is prepared. and you can save this chart anywhere. For example, you copy the clipboard, you copy chart here, you go to your Word file, click here, and you can paste your chart here. So likewise, you can do many type of graph. You can represent your data on the basis of pie chart, histogram, scatter plot for the better understanding to others. Thank you.